But what's the point of rationalizing the denominator in the first place? If you've ever taken algebra, you've probably been taught that you have to rationalize the denominator whenever you end up with a root in the denominator of your fraction. Well, rationalize the denominator is just a fancy way of saying get the root out of the denominator. For a fraction like this one, the easiest way to do that is to multiply both the numerator and the denominator by the same root that's in the denominator. This fraction, because it has the same numerator and denominator, is equal to 1. Just like 5 over 5 equals 1, or 7 over 7 equals 1, this fraction is equal to 1 too. And multiplying something by 1 doesn't change its value, which is why we're allowed to do this. And when we do, the square root in the denominator goes away. Because when you multiply two identical square roots, you're just left with the number under the roots. And that's always true. Multiplying the square root of 7 by the square root of 7 is 7, and multiplying the square root of 2 by the square root of 2 is 2. So when we rationalize the denominator using this process, we end up with the square root of 2 over 2. And just like that, we were able to get the square root out of the denominator. But what's the point of rationalizing the denominator in the first place? Well, there are a few reasons. A simple answer is that it's easier for teachers to grade work when everyone's giving their answers in the same format. Forcing you to rationalize the denominator means that teachers don't have to look out for both 1 over root 2 and root 2 over 2 as correct answers. But more than that, our habit for rationalizing the denominator goes back to the days when we didn't have consistent access to calculators. In the same way that we always want to reduce a fraction like this to its lowest terms, before we had calculators, we wanted to do the same thing with fractions containing roots. Because doing the long division by hand for root 2 over 2 is actually a lot easier than doing the long division for 1 over root 2, and so we've agreed that square root 2 over 2 is simpler, or reduced to lower terms, than 1 over the square root of 2. And since it was easier to work with rationalized fractions before we had calculators, we've just kept that convention even though we now regularly use calculators. It's also nice to have a convention for fractions with roots so that we can easily recognize like terms. If we don't agree to rationalize denominators, we might not realize that these fractions can be added together. But if we always rationalize our denominators, this fraction transforms, and we realize suddenly that we have a common denominator, and we can add these fractions together. I'll leave it up to you to decide whether or not those are good enough reasons to keep rationalizing our denominators. But nevertheless, those are some of the reasons why we do it.